Good morning, dear children. Now we will move to our fourth chapter, pressure in fluids and atmospheric pressure. Okay, pressure in fluids and atmospheric pressure. So in the first section, we will be discussing about fluid pressure. And in section B, we will discuss about the atmospheric pressure. Now, have you heard about the term thrust? Do you know what is thrust? Thrust means a force acting normal to a surface. Okay, force acting normal to a surface can be called as thrust. Okay, so in general, a push or a pull can be considered as force, and if a force is acting perpendicular or normal to a surface, we will call it as thrust. Okay, now since it is a force, what will be its SI unit? SI unit of force is Newton. Thrust is also a force, so its SI unit is Newton. And what about the CGS unit? It is dyne. Okay, so keep this unit in your mind. SI unit of force is Newton and CGS unit is dyne. And in the last chapter we learned the relation, isn't it? 1 Newton is equal to 10 raised to 5 dyne. Now, what about the other units? We told about the SI unit and CGS unit, and again we are having the gravitational units, isn't it? So, what are the gravitational units here? Gram force and kilogram force, isn't it? Gram force and kgf. GF and kgf are the gravitational units of force or thrust. Okay, now thrust acting per unit area can be called as pressure. Okay, so what is pressure? Thrust acting per unit area. So thrust by area can be called as pressure. Okay, thrust is force acting normal to a surface, and thrust acting per unit area can be called as pressure. This is the definition for pressure. So from here it is clear that pressure depends on two factors. Which are the two factors? Thrust and area, isn't it? So when thrust increases, what happens to the pressure? Pressure also increases because thrust comes in the numerator. So when thrust increases, naturally pressure also increases. Similarly, when you consider area is in the denominator. When area increases, what happens to the pressure? Pressure decreases, isn't it? So pressure actually depends on two factors. Thrust, it is directly proportional to the thrust and inversely proportional to the area. Now what about the unit for pressure? From this equation, unit for thrust is Newton. For area it is meter square. So Newton per meter square is the unit in SI system, and dyne per centimeter square is the unit in CGS system, because pressure is thrust by area. SI unit of thrust is Newton and area is meter square. So Newton per meter square or dyne per centimeter square will be the unit for pressure, and this Newton per meter square is known as Pascal. This is the name of a scientist. Okay, so instead of Newton per meter square, normally we will say pressure in Pascal. So Pascal is also the unit of pressure. Now when you move to atmospheric pressure and all, we will be using the unit atmos, then bar, torr, etc. Okay, but SI unit is Newton per meter square or Pascal, and CGS unit is dyne per centimeter square. Bar, millibar, torr, etc. are the other units of pressure, and it is used mainly in the case of atmospheric pressure. Now, we have to define 1 Pascal. How can we define 1 Pascal? So, from this equation, you have to define it. Already I told you how to define a unit. Units are often defined in terms of the equation. So, 1 Pascal is the pressure acting on a surface of area 1 meter square when a force of 1 Newton is exerted on it. Okay, so 1 Pascal is the pressure produced when 1 Newton of force acts on an area of 1 meter square. So if the force acting is 1 Newton and if the area of the surface is 1 meter square, then the pressure produced there will be equal to 1 Pascal. This is how we will be defining the unit. Okay, unit Pascal. So is it clear about the terms thrust, pressure and their units? Now, we have many examples related to pressure. Already we learned these things last year, isn't it? So by changing the area, by increasing the area, we can decrease the pressure. By decreasing the area, we can increase the pressure. So this time we are mainly dealing with the liquid pressure and the atmospheric pressure. So just have a look on these terms related to the pressure. Okay. Now we will move to the next part. In the next part, we will be discussing about the fluid pressure. Okay. So, what are fluids? What are fluids? Fluids means anything which can flow, isn't it? Something which can flow can be called as fluids. Now, fluids means liquids and gases. When you are considering solids, in the case of solids, that molecules are tightly packed, but in the case of liquids and gases, they can move. So substances which can flow can be considered as fluids, and the pressure exerted by fluids can be called as fluid pressure. So first we are going to discuss about the pressure exerted by liquids. So the pressure exerted by liquids can be called as liquid pressure. Okay, so liquids exert pressure in all the directions. And we have the derivation to calculate the pressure exerted by the liquids. It is not there in our syllabus. We don't want the derivation. We need just the equation. Okay. So the pressure exerted by liquid at a point. So if I am considering a beaker with water, liquids will be exerting pressure in all the directions. If you are considering a particular point, the pressure exerted by a liquid at a point is given by the equation P is equal to H rho G. Okay. P is equal to H rho G, where P is the pressure, H stands for the depth or the height. So here if you are considering this point, this is the depth or the height. Then rho stands for density, HdG or H rho G. If you say it as HdG, that is also correct because D or rho stands for density of the liquid. And what is G? G is acceleration due to gravity. Okay. So is it clear? Pressure exerted by liquids is given by the equation H rho G, where H is the depth, rho is the density of the liquid, and G is the acceleration due to gravity. So we don't want to consider the derivation. Please study the equation. So from here you can say that pressure exerted by liquids depends on three factors, which are the depth of the liquid, then the density of the liquid, as well as acceleration due to gravity. Now, many consequences of liquid pressure are explained in your textbook. So we will go through it. First one, when you are considering the pressure at a given depth in seawater, it will be more when you compare the same depth. Pressure exerted at a given depth in seawater will be more than the pressure exerted at the same depth in a river water. Okay, so you are considering seawater and river water, and you are considering the same depth. But even though the depth is same, pressure will be more in the case of seawater. What is the reason? What is the specialty of seawater? It contains salt. That means density is more, isn't it? Density of seawater is more than river water. So at a constant depth or at a particular depth, when you compare the pressure exerted in seawater and river water, you can see that pressure exerted will be more in seawater. The reason is its density is more. Now, when we are constructing dams, the bottom portion will be wide, isn't it? The walls of the dams will be broad at the near the base. Near the base. So what is the reason there? Why it is white? Because when depth increases, pressure also increases. In order to withstand the huge liquid pressure from the bottom, the walls are made wide. Okay. Then another example. What can we say? Yeah, when you're considering a bubble coming up, you can see the bubbles coming up from the water, isn't it? Not when it is heated. In the case of sea water or the river or in lakes, you can see the bubbles coming out. So when the bubbles come up, what happens to its size? Its size goes on increasing. Have you noticed that? The bubbles will be formed from the bottom, and when it comes up, its size increases. So what is the reason for it? When the bubble is coming up, what happens is its depth. At first the bubble will be here. So when it is coming up, what happens to the depth? Depth means you are measuring from the top, isn't it? So the depth decreases. When the depth or the height decreases, naturally pressure also decreases. And we have a relation connecting pressure and volume. Pressure is inversely proportional to volume. I think you have learned this in chemistry. What is the name given for this? P is inversely proportional to V, or PV is a constant. It is the Boyle's law, isn't it? So according to Boyle's law, pressure is inversely proportional to volume. So when pressure decreases, what happens to the volume? Volume increases, and that is why the bubble is getting, or the size of the bubble increases when it comes up. Okay, so once again you can see bubbles coming up from in a lake. So when the bubbles are moving up, you can see that the size of the bubble increases. The reason is when the bubble is coming up, the depth decreases. When the depth decreases, naturally pressure also decreases, because our equation is P equal to H rho G, where H stands for the depth or height. Then according to Boyle's law, pressure is inversely proportional to volume. So when pressure decreases, what happens to the volume? Volume increases. Okay. Now, the next one is in the case of diver's suit. That is, people who move to underwater. Divers, they will be wearing a special suit. What is the reason? Why can't they go with the normal dressing? The reason is pressure increases with depth. Okay. Pressure increases with depth. That is what already we learned. Because P is directly proportional to the depth or the height. So when we go deep, pressure from outside will be so high that it cannot be withstand with the blood pressure inside the body. So already we have the pressure from outside, and it is balanced by the pressure exerted by blood and other fluids in the body. When you are going deep, the pressure is so high that it can even crush a human being. Pressure from outside will be so high. So in order to protect us from this high pressure, divers are wearing special suits. Then another example what we can say is in the case of water supply tanks. So in the house, where are we keeping the water supply tanks? Is it kept on the floor or the ground? No. The water tanks are always kept at a greater height. So what is the reason? And where are the taps? Taps will be near the ground, isn't it? And the tanks will be kept at a greater height. So if the tanks are kept at a greater height, the water is coming from the tanks, isn't it? If the depth is more, what happens? Pressure increases. So when you open the tank, more water will, or water comes out with more pressure. Okay. That is why water tanks are kept at a greater height, because when height increases, in the case of water tank, since it is kept at a greater height, you can say that when height increases, pressure also increases. So if the tank is kept at a greater height, water will come out through the taps with a greater force. Okay. So these are the consequences or applications of fluid pressure. Okay. Now, next we will be considering about the transmission of pressure, and this is an important part pressure gets transformed in a liquid, and it is explained by a law called Pascal's law. Okay. According to Pascal's law, pressure exerted at a point in a confined or a closed and confined liquid is transmitted equally and undiminished in all the directions. You are considering a liquid taken in a beaker. Okay, and if you apply force or pressure at any point, this pressure will be transmitted equally in all the directions. And this is given by Pascal's law. Okay, so what is Pascal's law? According to Pascal's law, the pressure exerted at a point in a liquid is transmitted equally and undiminished in all the directions. Okay. So this law is important, and in order to prove that, an experiment is explained there. So we are considering a round bottom flask. Okay. A round bottom flask is taken. Then the specialty of this flask is it has many small pipes. Okay. Small tubes or pipes are connected to it like this. Many tubes are connected to it from this. Clear? So we are considering a round bottom flask. Then many tubes. Actually, many tubes are connected from this. We'll just stop with this much tubes, isn't it? If I draw many tubes, it will be difficult to understand. So this is a round bottom flask. Then many tubes are there connected to it. Then we are closing it with a piston, and this is filled with water. Okay. Water is taken in this round bottom flask. Now I am using a piston. Okay. A piston is used to close this. Now since water is there, what happens? There will be water in these tubes also, and you can see that the level of water in these tubes will be same. The level of water present in these tubes will be same. Now, when you are pressing it, this is a piston. So when you press it down, actually when you apply a force in the downward direction, what pressure is formed there, isn't it? Force acting per unit area is pressure. So when you just press it, a pressure is applied there, and according to Pascal's law, this pressure is equally distributed, and what you can see is the level of water in all the tubes will rise, and the level will again remain as same. Okay, that means you just exerted force here. Okay, when you are pushing the piston down means we are exerting a force here. Force acting per unit area is pressure. So this pressure is transmitted equally in all the directions, so that the level of water in all the tubes will rise, and the level will be, the rise in the water in the tubes will be same, because according to Pascal's law, what did we learn? Pressure exerted at any point will be equally distributed. Okay. Now, we have many hydraulic machines based on this Pascal's law. Okay. Hydraulic machines are there, and all these machines are based on Pascal's law. Okay. So, according to this, its principle, the principle of a hydraulic machine is by applying a small force on a bigger cylinder produces a larger force, by applying a small force on a small cylinder produces a larger force. So I'll tell you how it comes. So for this, I'm taking two cylindrical vessels. Okay. So already I told you, we learned about Pascal's law. Hydraulic machines works on the principle of Pascal's law. Okay, so we'll check the principle of a hydraulic machine. So, all the hydraulic machines consist of two cylinders. Okay, and what about the size of these cylinders? You can see that let this be cylinder A, this be cylinder B. B will be, or one cylinder will be always greater than or bigger than the first one. Area of cylinder B is more than area of cylinder A. Okay. Now, these two cylinders are connected using a pipe. Okay, and a connection is given so that both these cylinders are connected, and then we are keeping a piston. Okay, we have the pistons P1 and P2, or two pistons are there in the top, and now it is filled with water. Okay, so this is the structure of any hydraulic machine. So a hydraulic machine consists of two cylinders with two pistons, and the bottom of these two cylinders will be connected. It will be filled with water. Then when you consider the size, you can see that the size or the area of one cylinder will be more than the area of the other. So let this be cylinder A, isn't it? So let A1 be the area of this cylinder and A2 be the area of this cylinder. Now, we are going to exert a force F1 on this piston. Okay, that means here inside this we have water. We are just pushing. Okay, just push the piston downward. So F1 is the force exerted on the piston, and A1 is the area of the piston. Area of the cylinder. So a pressure, force acting per unit area is pressure. A pressure P1. Pressure is force or thrust by area, isn't it? So a pressure is developed there, and according to Pascal's law, what happens? This pressure gets distributed equally. So this pressure will be carried by the liquid and it reaches here, and due to this pressure, what happens? The piston B will be, the piston of the cylinder B gets raised. Okay, so what about the force? Let F1 be the force which acts on this piston, and pressure P2. Here let the pressure formed be P2. This is given by F2 by A2. And from here, what you can say, according to Pascal's law, the pressure will be same. That means P1 is equal to P2. Or you can say F1 by A1 is equal to F2 by A2. This is the principle of a hydraulic machine. Okay. So once again, I'll tell you, we learned about Pascal's law. According to Pascal's law, the pressure exerted at any point on a liquid is transmitted equally and undiminished in all the directions. Now, all the hydraulic machines works with the principle of Pascal's law. When we consider a hydraulic machine, it consists of two cylinders. The area of one cylinder will be more than the area of the first cylinder. The area of first cylinder will be always less than the area of the second cylinder. Now, two pistons are there on these cylinders, and the bottom of these cylinders are connected using a tube, rubber tube. Then, water is filled on it. We will be applying a small force on the first cylinder. Force acting per unit area is pressure. So a pressure is created there, and this pressure gets transformed and it reaches the second cylinder and it pushes the piston of B upwards. And here the pressure developed P2 is equal to F2 by A2. Now we know that same pressure is transmitted, isn't it? That is P1 is equal to P2. So you can write F1 by A1 is equal to F2 by A2. Now from here, what will be F2? F2 will be F1 into A2 by A1. So which one is more? Is it F1 or F2? F1 is the force which we apply, and F2 is the force. Due to Pascal's law, the pressure gets transmitted, and F2 is the pressure formed there. In the case of F2, it is F1 into A2 by A1. That means which one is greater here, F1 or F2? Naturally, it is F2, isn't it? F1 means it is F1 itself. F2 is F1 into A2 by A1. So, what can you conclude from this? A small force applied on the smaller piston produces a larger force on the bigger cylinder. Okay. So, by applying a smaller force on the small piston or the cylinder, you can produce a large force on the other one or the cylinder with more area. So this is the working principle of all the hydraulic machines. So 3 examples are explained in your textbook. First one is a hydraulic press or a Bremma press. Hydraulic press or Bremma press is used in order to press the cotton bales, to get the cotton, to press the cotton bales, or to squeeze juice from sugar cane. For all these things we are using a hydraulic press or Bremma press. Then hydraulic jack. In workshops and all you can see the hydraulic jack. What is the use of a hydraulic jack? In order to lift the vehicles, isn't it? In order to lift the vehicles in a workshop, hydraulic jack is used. Do you know how it works? It also consists of such a system. Here, the car or the vehicle will be kept on the kept above the bigger cylinder. You will be applying a small force on the small cylinder. So this car or the vehicle gets raised because a small force exerted on the smaller cylinder can produce a larger force on the bigger one. Okay, so that is the working of a hydraulic jack. Then again, hydraulic brakes also work with the same principle. So it is asked only about the examples in the syllabus. No need to study the construction and working of these things. Just remember these names. Okay. So is it clear? Now you can please take the textbook. Please take the textbook. Here. Page number 82. Take page number 82. In that, first part, already I told you. Take page number, it is needed. Okay, page number 82 and 83. Factors affecting pressure, no need of those examples and all those things we learned earlier. You should just study the definition, and unit and equation for thrust and pressure from this part. Okay, consider only that much. Then you can take page number 84. In that, page number 84, pressure in fluids, isn't it? So in that, just you study what is a fluid. A substance which can flow is called a fluid. No need of this experiment as well as this experiment. Study only what are fluids. No need for these things. After that, you study what is given in this box. That is pressure exerted at a point. It depends only on 3 factors. So it is not given in that box. Below that. Okay. Just study this equation. Pressure P is equal to H rho G. And yeah, only this is needed. Other things are not needed. Okay. So just about fluid pressure, fluids, then the pressure equation for calculating pressure. This derivation is not needed. Laws of liquid pressure is also not needed. But we need the consequences of liquid pressure. Consequences of liquid pressure is there in the syllabus. Then Pascal's law is there. This round bottom flask experiment is there. Now, principle of a hydraulic machine. That is what I taught now. After that, examples of hydraulic machine is given. No need for the construction and working. Just study the 3 names. Okay. Which are they? Hydraulic press, hydraulic jack and the hydraulic brake. Only these 3 names are needed. Okay. So is it clear what all things we need? First part, just the definition, unit and equation for thrust and pressure. Then what are fluids? Equation for fluid pressure, liquid pressure. Then consequences of liquid pressure, Pascal's law, its a demonstration, then the principle of hydraulic machine. Okay, so only that much is needed. Now, you can just mark the questions. We don't want the entire questions. Please take page number 92. I'll tell you which all questions you have to consider. And for these questions, if the answer is there, no need to write in the notebook. Else you have to copy it into the notebook. So question number 1, 2, 3, 4. 11, 12, 13, 15, 16, 18, 20, 21, 22, 25, 26, 27. Only these questions are needed. I'll repeat. Question number 1, 2, 3, 4, 11, 12, 13, 15, 16, 18, 20, 21, 22, 25, 26 and 27. If the answer is there, no need to copy it into your notebook. For the questions for which answer is not there, please find the answer and write it in the notebook. Okay. Then write the lecture note also. Okay. Thank you, children.